Let's make a start. Thanks for popping the recording on there, Robert. So, hi everyone and welcome to our webinar Wednesday. My name is Kirstine Stephen and I'm an Assistive Technology and Additional Support Needs teacher here at Call Scotland. Delighted to be joined this afternoon by Simeon Newbatt. Hi Simeon, thanks very much for joining us today.
Hi.
Simeon is the MakerSpace manager at You Create MakerSpace, which is described as a dynamic hub for creativity and innovation, and it's located in the University of Edinburgh's main library. So for the last year and a half, Simeon has been leading this interdisciplinary space, which provides students, staff and alumni with access to cutting-edge tools. And that ranges from 3D printing, laser cutting to green screen filming. I think you can actually see the green screen behind him this afternoon.
Yep.
And VR as well. So his role involves fostering collaboration, providing training and supporting users of all experience levels in really bringing their ideas to life. His passion lies in making technology accessible and fostering inclusive, creative communities, and I've no doubt that that's going to come across this afternoon. So today's session is being recorded thanks to my colleague Robert, who's in the background keeping an eye on everything technical for us. The recording link will follow today's webinar by email for everyone that registered, including those that aren't able to join us live this afternoon. I would ask you to please ensure that your mics remain muted throughout today's session, and if you don't wish to be in the recording, then please just keep your camera off for now. The webinar is going to run for 20 minutes and then there'll be an opportunity to ask any questions, but if you do have anything throughout the presentation, please just pop them into the chat pane and I'll facilitate those at the end. So I'll hand over now to Simeon. Thanks, Simeon.
Yeah, thank you very much for having me. Yeah, I mean, that was quite an introduction. Anyway, yeah, so I am the manager in the Makerspace in the library, which means I am super excited about tech and I do a lot of admin, but mainly, as much as I can, you can find me elbow deep in a 3D printer or a laser cutter. So if this presentation will, there we go. So firstly, I'll just make you a little bit jealous of where I get to work. So yeah, we've got green screen, we've got 3D printers, we've got lots of electronics, and we have everybody coming in and using all of them. So that's kind of where my main speciality is in supporting people to come in and use the tech to make whatever it is they need to make. But we're going to dive into how this kind of tech, and specifically 3D printing, can help within classrooms working with children with additional support needs. So yeah, we're mainly going to look at why 3D printing, what 3D printing is, how to 3D print, and then look into what it can be used for. But I think my main expertise sits in the why, what, and the how, and I'll leave the what it can be used for, hopefully after my explanation of the others, to you guys to go and get creative with. So why 3D printing? Is all my notes coming up on the side. Why 3D printing? It's become so easy to customize items within 3D printing. It is really just a few clicks and you can adapt things, you can personalize them, and then you can print them on demand. And it's become such an enjoyable process now, I think, from a few years ago where it was very challenging, where it didn't work very often. It is now a lot of fun to get into it. Affordability, 3D printers have become very cheap. Talking a few £100, a couple £100 to buy into 3D printing, and the materials are very cheap. So yeah, it's very easy to access it. Which moves me on to accessibility, which is all the different processes within 3D printing have now really left the technical and the hobbyist and the enthusiast, and it's really user-friendly, very straightforward, and yeah, there's a huge supportive community around it. And there's lots and lots of designs that you can 3D print, which we'll go into shortly. But yeah, across those 3 points, it is just so easy now to get into. And I think some people maybe feel that it's quite a technical thing, but the way the technology's come along, it is really just a few clicks and you can be printing. So yeah, what is 3D printing? I Googled it to get the official term. It's kind of funny. I live so much in it that I kind of forget what the official term is. So yeah, 3D printing, also known as additive manufacturing, is a process of creating three-dimensional objects by building them up layer by layer from a digital design, using materials such as plastic, metal, resin, or even biomaterials. A 3D printer precisely deposits material based on the computer-aided design file. This technology is widely used in industries such as manufacturing, healthcare, aerospace, and prototyping due to its ability to produce complex shapes, reduce waste, and accelerate production. It has revolutionized the customization and small-scale production, making it more accessible and cost-effective. Kind of proves my previous slide. That's quite a mouthful. In reality, it's just a lot of fun to get into, and you can make stuff really quickly, really easily. I've lost my mouse. Yeah, so there's quite a few different types of 3D printing. There's FDM, which is, when you say 3D printing, most people think of FDM printing. It's cheap to get into, the equipment is cheap, the materials are cheap, the learning curve to start using it is very low, the complexity of the equipment and the process around it is very low. I've put in a few of the other main types of 3D printing just to give you an idea of what they are. The kind of second main one is resin printing, and that uses liquid resin and a laser fired through it, and that gives you very high detail prints, and so it's used a lot in jewelry. It's used in dentistry a lot, so they make the molds for false teeth from them, or caps, teeth caps. Used in medicine a fair amount. SLS is laser sintering, using powders. There's a huge amount of health and safety risk around those ones, and yeah, very expensive to get into, mainly used in engineering. And then direct metal laser sintering is an even more extreme version of that. So the one we're going to look at is the FDM printing, which to everybody is just 3D printing. And that is a process using different types of plastic, the most common being PLA. It's a biodegradable plastic. There's also other materials such as PETG. This is getting quite technical now. ABS, which is a bit of a stronger material. So is nylon, so is TPU. I'm just putting these terms out there because they're things that you might hear if you go and start 3D printing. But PLA, nice, cheap, simple plastic to print with, and you can do most of what you need from that. The process works. So this is plastic spools. The filament comes on spools like that. They're normally about 1.75 diameter, but they can be slightly bigger depending on the printer you're using. And it's going to take that spool of plastic, it's going to feed it to a hot end, and it's quite simply just going to melt it and push it out where you've directed it to, or where your file has directed it to. That sticks down onto a print bed, and then it just builds up your model layer by layer, extruding it out. Yeah, it is really that simple. It is simpler than your inkjet printer at home. So all that kind of technical fear around it, it is click print, and you can print things into 3D. Again, just to kind of, yeah, The FDM printers come in many different shapes and sizes and costs, but they're all doing exactly the same thing. They're moving that hot end around and they're extruding out plastic. Within those ones, they're ranging from £200 to £10,000. So there's quite a range in that. The orange one in the middle, one of my favorites, it's £200 and it'll happily print for you all day long. We've got 10 of them here in the MakerSpace and they run 24 hours a day and do a beautiful job. Later on, I'll show you a bit more 3D printing, and that's the second from the left, the one I'm using in that, which is a Bamboo Labs printer, which was about £1,000, and that can print in multicolors. We also have one of the £10,000 ones on the right. It's not really worth it. But yeah, so how do you 3D print? I've separated this out into three main areas. First one is to get a model. And one of the easiest ways to get a model, especially if you're starting out in printing, is to just go onto one of the big repository websites, and Thingiverse and Printables are the main ones. And there is tens of thousands of designs in there, ready to download. Most of them have instructions on exactly how to set your prints up, what type of materials work best with it. There'll be ratings or remakes of the designs. Fantastic community on them to get you started. I was also pointed towards another great site the other day, which is Makers Making Change, and they've got a big selection of assistive devices on their site. Some fantastic things in there. We'll go over a couple of their pieces later on. But yeah, well worth checking them out. If you've got access to a 3D printer, just try out some of their designs because they are fantastically made. Another way to get your model would be to create your own model. A variety of different ways you can do this. One of the best ways to kind of get started in that would be Tinkercad. Tinkercad is a free web-based 3D modeler. It's made by Autodesk, which makes some of the industry-leading 3D modeling software. But this has got all the weight of Autodesk in a very nice, easy-to-use, accessible format. And it's essentially just building up different bits of geometry, adding them together, removing parts of them, and that'll get files which are perfect for 3D printing. Quite often when people use more advanced software, I advise them to run their models through Tinkercad to get a cleaner model. So it's a great resource to go to. Beyond that, Fusion 360 is essentially Tinkercad, but a more advanced version, and that's used a lot in engineering. And then there's Blender 3D, which is open source 3D modeling software used more in arts and animation, but can also generate models for 3D printing. But the last and what will probably be really interesting to you would be 3D scanning, because that's a great way of designing assistive aids for very specific use cases. So that's taking a structured light scanner, which would be a whole presentation in itself. But you're able to scan in 3D models of objects. This one can just do, in the picture, can just do very small objects, but we work with scanners that can do full room scale scans. And just to give you an idea of what that might be used for, next week, a little bit last week, but mainly next week, I'm working together with a charity that makes assistive aids to scan parts of a wheelchair so we can make accessories that clip onto it. So it's a very complex shape on the wheelchair, and they want to 3D print custom parts that will attach to it. So we'll bring the wheelchair into our MakerSpace, scan those parts of it, and then we can model around those parts. So it's an incredibly powerful piece of kit when put together with the 3D printing. So yeah, that gets you your model, and all of those formats, whether you're downloading them, modeling them, or scanning them, you can export them as an STL file. and that's the kind of the basic file that we need to start building it up for 3D printing, which takes us on to slicing. Slicing is very specific to 3D printing, and that's software which will come with a 3D printer, or you can download it, and it'll quite often be specific to a brand of 3D printer. And that is where you prepare your 3D model for printing. So in this clip here, it's adjusting colors on the print. So if it's using multiple colors in the printing, you set that up in your slicer. You'd select your material type in your slicer. You also need to do things like look at supporting structures, because in the very kind of linear layers that it builds up in, you will end up, you end up with these bridges around here, and so it automatically builds up this green tree structure that will hold everything in place. It sounds all very technical. Almost everything I set up in these files, I just set to auto, and it does it for you. So similar to your inkjet printers at home, you just kind of click go, and it does it. Print orientation, this is something that, because the slicer doesn't understand how you want your files set up, just thinking about how they're sitting on the printing plate. So this one is, I just realized how bad a picture this is because it's all in red, but there is a bit that it's had to build support structure in here. But by flipping it over, that'll be open and it wouldn't need any support structure. So yeah, orientation of prints is important. And one of the most challenging things you'll end up with in 3D printing is getting it to stick to the bed, because you've got hot plastic that's going onto quite often a metal plate that's a little bit cooler, and as it cools down, it changes form and it sometimes lifts up. So you just click auto bed adhesion and it will normally do it all for you. But that is one of the more frustrating points in 3D printing. And that's it all sliced, and that will then generate a G-code file, which is a very simple code file. You don't have to deal with any of the code, but that's what a 3D printer will understand. And all you need to do is click print, and it gets printing. And the process is really as simple as that. But yeah, to look at what can be printed. In my previous job, I worked in more kind of arts and crafts settings with adults with additional support needs, and I spent a lot of my time making aids with 3D printers, with CNC routers, with hand tools, kind of assessing how people were working and what I could do to assist them to promote their independence in what they were doing. And these are just a handful. I couldn't, for certain reasons, bring the ones from my previous work, but these are just free downloadable examples from Thingiverse that you can start making. And there's a fantastic amount of stuff out there, and quite often they're really, really simple things that can easily be 3D printed and can make a massive difference. And I did make the Lego Braille as well a while ago for a kid who was learning Braille, and the amount of Braille resources out there is amazing, and the tactility of 3D printing just lends itself to things like Braille, which leads us on to kind of more specific ASN models. These ones, I've stolen them all from Claire Harrison from Cole Scotland, who invades my MakerSpace in the holidays quite often, and has been doing a fantastic job with making these communication aids, which I believe you've got a few sets of them now that can be loaned out. And these, you can just print them out all day on a 3D printer. The machines love them. They come out beautifully. This is using the power of having multicolor printing. So you can get these really bold designs on them. You can adjust the symbols on them. It's really, really customizable, really easy to get into, and just a lot of fun to make. So Claire has a fantastic blog post, which I believe has gone up in the links, or is going up in the links. all about her process of making these, and yeah, just a wonderful example of how 3D printing can help create aids in the classroom. And I've got a second example, which I've also stolen from her because she's got fantastic ideas or finds fantastic resources. And that was these simple interact switches. And I especially like these because it's mixing different parts of the MakerSpace in. So there's also a little bit of soldering that goes into these, but it's a really simple design that's so customizable. They've already got sorry, yeah, it's on Makers Making Change. They've already got, I think it's about 20 different versions of the top of the button. The bases are all identical, and they're just very, very straightforward to go in and make different bits of it. You could take those tops into Tinkercad and modify them to what you want. Yeah, just a beautiful, simple design and a way that you can very quickly, very easily create something that could be a bit more challenging to source or a bit more expensive in many cases to source. So yeah, those are the two examples of kind of more specific classroom bits, but also just to kind of get back to how simple it is to find these resources and to make them yourself. I just put a quick video together of me going in, downloading models from these are the interact switches, adding them into the slicer and then printing them, because it's a matter of minutes to put this together, and this is not taking lots of technical expertise. That's all the different tops they have for the interact switch. And so this is just dragging and dropping their ready-made files into the slicer. Just have a quick check over the slicer to see if there's any support needed. Check over the rest of the designs. It's a little bits needed in there. And that's the support added. And that's just adding a little bit more adhesion. And then I can just select a model. I can select a color. And I can go a bit rave on it. And just move everything a bit closer together so it prints a little bit nicer. And this is a process where it figures out all the different layers that it's going to need to print. So now it's converted it into the code that it needs for the printer, and that's scrolling down through the layers. So you can see all that support that it's built up in the middle of the button, where we'll take that out later. You can also see how the print head's going to move around, but that's not really anything you'd need to check into. And that's sending it through to the printer, just double checking that the colors match what I've put into the printer. And I've saved you watching the 3 hours of it printing. Although it is incredibly mesmerizing to watch a 3D printer work. That's it done after 3 hours. That's how it looks when it comes out of a printer. That's a support structure taken out with a pair of pliers, and that's it finished, ready for a little button to go into it. So that's how easy it is to get 3D printing. So yeah, some final thoughts. I'm aware that not everybody has 3D printers, but most cities have makerspaces, hack labs, fab labs. They tend to have 3D printers in them, and they tend to be very enthusiastic and incredibly supportive. So if you have some nearby, then reach out to them, see how they can help. Yeah, lots of great open source models, so you really don't need to kind of get caught up in I can't model or I can't make or anything like that. There's tons of stuff out there, and I would just start downloading and printing stuff if you can find access to a printer. And it is so much easier than you think. I've put a bit of terminology in here, but most of that was just to kind of warn you of it will pop up, but it's like I said, click auto and print. And then at the end of it is not the answer to everything. It does have its limitations. It does have some strength limitations. It sometimes is challenging to work with, but it's a fantastic tool in your toolbox because it's a way to just very quickly create even just ideas, something that you thought might work, and you want to try it out, something that you know you'd need to make with a different material to have a final design, but you just want to prototype it to see if it's going to work. It's a really, really easy and accessible way to get into creating things. Yeah, that's all I have for today. I've put my email up and the studio email up because we're always happy to answer questions. So if it's something you feel you'd like to get into, just send us an email, and we will do what we can to help out.
That was great, Simeon. Thank you so much. I think with anything like that, there's obviously lots of technical terms, but I think you've demystified the scary parts, and that actually there's lots of examples out there already that you can take and you can use, and put the settings to auto, as you say.
Yep.
Anyone got any questions, please pop them in the chat. Or if you want to unmute your mic, that's absolutely fine to do so now. I was just going to ask you, obviously with the cost of purchasing educational resources constantly increasing and education budgets decreasing, how effective an investment could a purchase of a 3D printer be for a school, would you say?
I think if there's people who are enthusiastic about using it, not necessarily that they have to have any knowledge or expertise prior to it, but if they're enthusiastic about using it, then it can be great. Yeah, they're really cost effective for being able to make stuff, and they're the type of thing that you'd be able to expand out into. It wouldn't just be for creating resources, but it can be, a teaching resource in itself.
Teaching tool, yeah.
Yeah, absolutely. And then also, if you're going to do that, if you do, because there is times where you'd need to fix a machine and things like that. Buying from the right companies that they provide support with it is really important, because there are some companies out there that have a fantastic level of support. The company we work for, I'll give them a shout out, Additive X. They I think it's about 20 minutes you'd get a response to an email with a question about equipment.
That's impressive.
You get parts sent out to you within 2 days. So yeah, finding the right people to work with on that, and then picking the machines, because there's a lot of really, really cheap equipment out there. So I do a bit of research onto what's good cheap and what's avoiding cheap. So yeah, but no, I think it's a great resource to have.
Okay, thank you. Richard, do you want to have a question you want to ask?
Hi. Yeah. How much are you using the printer? So how many devices are you making a year, and what kind of devices are you making?
Devices we're making. So we're kind of an open makerspace. So we're providing space for students, staff, and alumni within University of Edinburgh to come and make stuff within our space. So we have, do we have 16 3D printers running almost 24 hours a day, making all sorts of stuff. everything from Pokemon characters to we've got a lot of people from brain sciences who are making wonderful mazes for rodents. So it can be anything. So we're not specifically working within ASN, but Claire Harrison, I mean, she was in printing off a hefty chunk of communication aids the other day. Yeah, you can print them out pretty quickly and very effectively. If that answers your question at all.
Yeah. How would I get in touch with Claire? Because I'm working for an NHS service and I'm looking at starting the 3D printing side of our service. So we're currently in the research phase of the project, and essentially we want to know kind of how much use are people getting out of this.
Yeah, I can pop. Oh, sorry, I was just going to say. So the symbols that Claire has been producing are going to form part of our core word kits that we loan out to schools in Scotland. But I can give you Claire's contact details. I'll pop them into the chat.
Thank you.
Yeah.
What was it you were going to be printing out, Richard?
Everything and anything. So grids for ASC users for their keyboard sets. Yep. Joystick adaptations for mounting. Yeah.
Okay. Yeah.
All sorts of stuff.
Feel free to send me an email, and I can go through also a bit more technical on the 3D printers and processes around that, because that can make a huge difference to your ability to kind of almost mass produce on it, is getting the right printers and the right setups.
Can I just bring my colleague Paul in there, because I know that he's been out in a school where staff and pupils have made a bespoke wheelchair joystick.
Yeah, it was really just, we're the same. You know, we've been thinking we should do this for ages, particularly for key guards, because they're so expensive to manufacture. So one of the reasons for getting in touch with Simeon and his colleagues was about key guards and joystick handles and switches and the adaptations, you know, that you can get for the Microsoft active buttons. But we're still at the kind of early stages of it. So I believe that colleagues at the ACE centres are quite heavily involved with this, so I forget who it is, but you might want to get in touch with them.
Yeah, it's Diane. I forget her second name, but I spoke to her a couple of weeks ago about this.
And we're the kind of the same as you. We're at the early stages of thinking. Yeah, of course, you have to know how to do it to kind of know what's possible. But just what Simeon shared with us today makes you realise, oh, that's what's possible. So
yeah. The letters thing's kind of piqued my interest, and I'm going to share it with the SLTs at work, and I'm sure they'll be kind of impressed by that and intrigued.
So I don't know. I notice occasionally with the the specialised AT services forum, there's sometimes chat going on, but it does strike me that this is one of these areas that there's a lot we can share and learn, and well, obviously a lot we can learn from Simeon. But yeah, very exciting indeed. So I don't know, we don't have any answers to your questions, but would like to find out, same as you.
Yeah, all learning together. Okay, well, thank you all very much for joining us this afternoon. Simeon, thank you so much for your presentation. That was brilliant. I'm sure you will have a few emails in your inbox.
Yeah, bring them on. Thank you for having me.
So thanks very much, everyone. And our next webinar will be on the 5th of March, where we have Michael Cash from VoiceIt joining us on looking at speech to text for learners with indistinct speech patterns. So that'll be another good one. Thanks very much. Have a good evening, everybody.
Thank you.